All right, who can tell me what a factor is? What is a factor? Is it a what? What do you mean a part?
Like a number will be multiplied to that, like if you multiply it by
Well, you're right. Shh. A factor, by definition, is paired with another factor, and two factors can be multiplied to make a number. Let me show you an example. An example of this would be like... Oh, sorry. Well, I haven't actually written anything yet anyway. But a factor of a number is so like 8 has factors of 1 and 8, 2 and 4. Those are all factors of numbers. Anytime... Now, factors have to come in pairs. Factors have to come in pairs because, by definition, it's being multiplied by another number to equal our number. Now, there's going to be a lot of factorization today where I'm going to give you a number and you're going to have to find factors of it. That's just the way it is. I'm going to do my best to show you shortcuts for a lot of the things we're doing today, but at some point we're going to have to be able to find factors. Yes, ma'am? If I had to put it in a definition, a factor of a number is multiplied by another factor. No, hold on. A factor of a number is a number that can be multiplied to get that number.
So this lesson going to be like factor trees and stuff?
That's not really the focus of it, but you're going to need to be able to do that, yes.
I remember this.
Good.
I always hate it.
Now, easiest way to see if a number is a factor. Shh. Easiest way to see if a number is a factor. I don't care what you did, be quiet. Your dom isn't even out. Easiest way to find if something's a factor. Take a number, divide it by a number, and if it divides evenly, like 8 divided by 2 is 4. It divided evenly, that number is a factor. Also, if you did 8 divided by 2 and saw that it was an even number, that number would be a factor, but also its result would be a factor. So you really find 2 factors every time you find one. Like 12. What's 12 divided by 3? 4. It divides evenly, so 3 is a factor and 4 is a factor because they multiply to get 12. Let's look at this one. Yeah. List all the possible factors of 243. So, yeah, we'll always start with 1, although you pretty much will never need that one. But yeah, 1 and 243. Now, we're going to start working our way up. What about 2? No. Good. Hopefully you'll remember some of your little tricks. So 1 and 243, although you can pretty much leave that one out every time because that one's kind of obvious. What about 3?
Yes. 3.
Calculator.
3 and 81.
Thank you. 3 and 81. What about 4? What about 5? What about 6?
No.
No, and no. Well, I did all throw 3 of those at once. 4 and 6 are impossible because it's not even. And 5, does it end in a 5 or a 0? Y'all remember any of this stuff? Yeah, so 4, 5, and 6 are out.
Like we had to add them on.
9, 27.
And like if it did.
Say that again?
Like one of the numbers is where you have to like add like those numbers up.
I think you're thinking about like factoring. You're thinking about factoring, but a more higher order of factoring. We're not going to get to that till later in the week. Craig, what'd you say the next one you found was?
9, 27.
9 and 27. Now here's the thing. You'll know you're done if the numbers in this column start surpassing the numbers in this column in size. So 10, 11, I don't think 11's 1. Is it?
Nope.
Nope. How about 13?
Nope.
17?
Nope.
19?
Nope.
21?
Nope.
23?
Nope.
And we're done. Those are the only numbers you really had to check for that one. Because after that, you're going to get to 27, but we've already found 27 and up. So, you just start there. So, there's the factorization of this problem. Now, at this point, hopefully, you're starting to put pieces together and think, how am I going to need this? Well, I'll tell you how you're going to need this, because the problem you're going to have today is going to be like this. What's the square root of 243? And I don't want decimals. You're going to have to reduce the radical. So what you have to do, look at all your factors, okay? Now, here's the thing, you're not going to have to factor every problem. You don't have to just keep factoring. Let's say you immediately find, here's the thing, we're looking for the square root of this number, so we're looking for a number that divides into it that is a perfect square. Does anybody see a perfect square in this list? Yeah, there's actually 2. What is that? Oh yeah, 9 and 81 are both perfect squares. Perfect squares, 4, 6, 4, 9, 16, 25, 2 squared, 3 squared, 4 squared, etc. So, let's say, for instance, you were working your way up and you didn't even make it to 81. You found 9. Hey, 9's a perfect square. Somebody tell me, what's 9? Oh, never mind, it's right there, 27. So you'd have to rewrite this. The square root of 9 times 27. What is the square root of 9?
3.
So this would now be rewritten as 3 radical 27, because the square root of 9 comes out as a 3. We may not be done yet. Does what? No, it will never be negative. Now, 27. Does 27 have a perfect square factor?
No.
It's the other answer. What's that?
3 over the radical of 3 would be 27.
Yes, but what actual number is the factor of 27 that's perfect square? Here's the thing. You're not going to have to do this every time. You're just looking for the perfect squares, right? So you could have immediately started with 4, no, 9, yes, which is how we got this. Just look at the perfect squares. Is 4 going to divide into this? What about 9? Yes. What is 27 divided by 9? 3. So this is the same as, we still have that 3 out there, 9 times 3. What's the square root of 9? So we're going to bring out another 3. 3 times 3, which is 9. Now, this does not reduce. Oh, I'm sorry. Well, it's behind here. There are no perfect squares that go into 3. So the answer to this would be 9 times the square root of 3. And you have reduced this to this.
Is this all we're doing?
No, this is like 1/10 of what we're
I
doing.
like decimals.
Lord have mercy.
What?
I like decimals too.
I know. So do I. I kind of hate this lesson.
I don't
For
know how
this
to do
reason.
that.
Last year I got a 0 for these cases.
We're going to keep doing it. Let's look at another one. Let's look at another one. How about this one? Shh. Let's see. Let's take this off the board. Let's look at another one. Let me think of an example. How about the square root of 128? Now again, let's just worry about the perfect squares. What's the first perfect square we should try?
1 and 128.
2.
Well, you're always just going to skip 1, because 1 doesn't really help you. Or, well, is 2 a perfect square?
No. 4
But
is.
4 is. So let's try 4. What's 128 divided by 4? Was it? 32? Oh, it goes into 4 and 32. So we can do this. 4 times 32. What's the square root of 4? So that's 2. Now, does any perfect square number go into 32? We have to start over. What about 4? Does 4 go into it?
Yeah.
And as what?
8.
4 times 8. What's the square root of 4? 2. So that brings another 2 out in front. 2 times 2 is 4 radical 8. Does 8 have a perfect square that goes into it? Yes. That'd be 4 and 2. And let's see. That would come out. That'd be another 2. So 4 times 2.
Okay, this guy's kind of complicated. Yeah, there's got to be an easier way to do it.
Well, let's go back for a second. There is technically, but it would require you to find all the factors. If you remember, this one... Oh, hold on. Go away, darn it. This one right here. Remember how when we first factored it out, yes... Hello? Oh yeah, he's always... I haven't seen him in weeks. Oh, I didn't even know that. I was never told that. Okay, well now I know. Oh, I did not. Oh, what's your extension? Thank you. Okay, if you remember, when we factored this, we did 9 to 27, but wasn't there also 81 and 3 on here? The easier way to do this, rather than have to keep doing it, if you find the biggest perfect square that it goes into, in this case 81, then you can make it a one-step problem. What's the square root of 81? So that would have been 9 radical 3 right off the bat. square root of 81, square root of 3, 9, instead of doing it so many times. The one we just did, if we had fully factored it, the one we just did, what was it, 128? If we had fully factored it, we would have found that 128 factors down into 64 times 2. What's the square root of 64? 8 radical 2. But that would require you to find all the factors and then take the biggest square root. Now, when we were doing that, I was hearing people bellyache about, they're so hard. That's why I broke it down into the smallest one and just keep finding the smallest one. But if you think that's easier, by all means do it that way. Questions? Yes, ma'am.
So how'd you get the 2?
64 times 2. All we did was factor it, and then once they work, you just put radicals over both of them, and that's, because I'm not just going to give you a number, it'll be the square root of that number. And that's what you're going to be asked to do. Let's look at one. Now, here's actually where this lesson is going. This was actually just a side little piece of the lesson. Here's the kind of thing you're going to be asked to do. Now, relax. The letters are the easiest part. I'm going to show you a really easy way to do the letters. But there's no way to do that with the numbers without doing like that. Now this one's not so bad, because what's the square root of 16? 4. Yeah, this one you don't really have to do a whole lot of thinking, but there are going to be some bigger, uglier numbers. So 4. We know. Now, here's the easiest way. The easiest way to do a square root. The book will not tell you this way. Let me show you what the book wants you to do. Let me show you what the book wants you to do, and then I'll show you my easier method. The book wants you to break all of these down into as many perfect squares as you can. P to the 4th squared, P to the 3rd squared, and then cancel all your little squares. So that would be a 4 comes out, a P to the 4th comes out, and a Q to the 3rd comes out, and then there was one Q left. That's how the book wants you to do it. I personally think there's an easier way. Here's what. Just last week, I taught you that if you had something like this, all you had to do was multiply the exponents, right? You can use that exact same principle for square roots. Here's all you have to remember. A square root is nothing more, yes, bless you, than a fractional exponent. A square root, which is the second root, is really p to the 8th, q to the 7th. What? Oh, no, that was just a quick little example. What? It was what this was, and I moved it. If you were to rewrite every radical, which a square root is called a radical, as a fractional exponent, you can just do what we did last week. Multiply your exponents, and it's just that quick. Well, we already know the square root of 16. That's 4.
Why is it a half?
Because a root is... That's what a root is a fractional exponent. In fact, if you punch in your calculator, square root of 16, 4. If you punched in 16 to the 1/2 power, it would tell you 4 as well, because that's what they are. Now, we just multiply our exponents. What's 8 times 1/2? 4. So that would be p to the 4th. What is 7 times 1/2? 3.5. Now, you have to take the whole portion. Now, here's the way I think of doing this. We basically took 3 2's out of 7, which is what, 6 out of the 7? So how many did that leave? 1. So you have to leave 1 under there because we couldn't bring them all out. We can only bring them out in 2's.
So it's always going to be a half? Or
Well, we're going to be doing cube roots and 4th roots and everything, so it'll be 1/3 or 1/4. But you still just multiply the exponents every time. Every time. You're going to miss examples, but sure. Or you can go when we're done. Just go when we're done. All right. That's what we're doing. Now, you might notice they put the 3 in absolute values. Technically, that's true. And that's because you cannot have a negative number come out of a square root. It's impossible. Square root of 9 is 3. Square root of 16 is 4. You can't. So they're saying anytime you get something odd out of there, you need to make sure that you understand that it has to be positive. It's really a minor thing. Whew. But to appease the math people, it's all right, we'll wait. To appease the math people, we're going to put the odd ones in absolute values.
Lord God.
You okay? You? Good. Glad to hear it. I can't, man.
We go to right, you start. Yeah, just take the box.
Yeah, just take the box to the hallway, dude.
No, I'm finished, man.
I'm not like upset. It's hard to talk over. Are you good? All right. All right. Okay. So let's look at another one of those. I'll have to come back to these other examples. Let's find one that looks like that on this page. Now, number 4 is just like the ones we did a second ago. You don't even have to worry about the 5, you just worry about the 60. In fact, let's do that one first. 5 square root of 63. What is a perfect square that goes into 63? 9. That's right. So that's the same as, well, what is 63 divided by 9? 7. And what's the square root of 9? The 3 comes out, so 3 times 5, radical 7, which is where this came from. That's where that came from. Now, let's look at, actually, we're not going to do something like number 6 today. We haven't done those yet. I'm looking for one. Let's look at number 5. What? Yes. Let's look at number 5. So, first of all, how do we do a big root like that in the calculator? I will show you. If you remember that they're fractions, it's actually not, oh, what the heck just happened? It's actually not so bad. I'll bring this back up. So we are looking for the 4th root on number 5. So first thing I'm going to do is the number. Does 16, is that a nice perfect 4th root? So I put it to the 1 divided by 4. That's the same as the 4th root. Yes, it is. Sweet. 16 was a nice perfect 4th root. So that's just going to come down as 2. Oh, hold on. As 2. That's where this 2 came from. Right there. Now, I guess technically there is one other way I can tell you how to do this. How many 4s can you subtract from 5?
1, 4.
Yeah, just one group of 4s. Another way to look at this root stuff is how many of these can you take out of this? For instance, let's say it was like, let's say for instance you had like the 5th root of x to the 12th. Okay? How many 5s can I take out of 5? 5, 10, but then I go over it, don't I? Yes.
So it'd be 2x for the first y, the first radical x.
What I'm saying is, another way, if you didn't like my fractional method or if you don't like the way the book does it, is how many times can you subtract 5 from 12 before you go negative? 12 minus 5 is 7. 7 minus 5 is 2. 2 minus 5, ooh, that's where we're going to do a problem, right? So I could do it twice.
How'd you get extra?
Pause. What?
2x
Yes.
radical.
So I could take 2 x's out, and after I subtract 10, how many were left in the 12? 2. That's how that would work. I can subtract 2 5s from 12. Knock it off. Leave them alone. I can subtract 5 from 12 twice, and when I did that, it'd be 5, 10. 12 minus 10 has 2 left. That's another way you could do it. Or again, you could do my fractional way. 12 times 1/5 is 2.4. 2, and then 0.4 is 2 over 5, which it's up to you. But anyway, going back to the problem at hand. So, how many 4s can I take out of 5? Well, I can take 1 out, which is where this x comes from. But after I subtract 4 from 5, how many is left? 1, which is why there's still 1 under the root here at the end. How many 4s can I take out of a perfect 4? Exactly 1, which is why I pulled 1 out, and there's none left in there. Maybe we should just focus on this skill today and not even worry about the rest of them just yet. Although we will still work on ones like number 8, because that's just a combination of the two things we've done. Number 8 is just a combination of all that stuff. What's a perfect square number that goes into 25? Oh, is a perfect cube. Oh, crikey, that's not going to actually work out. We're just going to work on the top one. All right. Let's look at another one. Blank page. How about, all right, 24. Actually, yeah, well, I'd like to actually use a number that we could do. 32. Let's do 32. We're going to do to the 4th root. X to the 7th, Y to the 9th. If you can get this, you'll be okay today. All right. We're looking for the perfect 4th factors of 32. Use your calculator. What's 2 to the 4th? What's 2 to the 4th in your calculator? 16. Does 16 go into 32 evenly? How many times? 2. That's right. 16 times 2. What is the 4th root of 16? That's right. It's 2. So this is the same as 2. Oh, I'm sorry. That's the 4th root, but the way I wrote it was probably confusing. So I brought 2 of them out, and I still have 2 of them left in with my variables, which I haven't done anything with yet. All we've done so far is the number. We looked for the perfect 4ths of 32. 16 worked. So 4th root of 16 is 2, and 2 is left in there, which is where that came from. Okay, how many times can I subtract 4 from 7?
3, 4, 7, twice.
I can only subtract 4 from it once. But now, Mark, what you were saying, when I do that, how many am I left with? 3. So, I can bring 1 x out, but I have 3 that are going to be left in there because I can't bring those out. How many times can I subtract 4 from 9?
5,
I can do it twice. 4, 8. I can bring 2 of them out. It's y squared. Highest round of space. And how many are going to be left in there? 1. 1. There you go. There you go. Let's just focus on this skill today. Right there. So rather than me pull up all the problems from the day, we're just going to focus on these, and I'll just make up 4 that are going to work out similar to that. Questions about how those are going to work out? All right. Does anybody want to maybe look at one more example? One more example. All right. Come in. No, we don't have any. All right. How about the 5th root of 64 x to the 13th y to the 26th. We're going nuts because this is the last example, hopefully. First thing we have to find, what are all the perfect 5th roots of 64? What's 2 to the 5th? Yes. What? No, that's 2 with a 5 next to it. 2 to the 5th power. What is it? 32. Which, does 32 go into 64? Yes, it does. 32 times what equals 64?
2.
So, 5th root, and we know that the 5th root of 32 is 2, so that's going to be 2. I'm just going to do this all at once. And there's going to be 2 left in there. This one came here. That one is still in there. All right. How many times can we subtract 5 from 13? Twice. And when we do that, how many are going to be left in there? 3. because we took out 10 of them, 5, 10, by doing two
So why
fives,
did you take up 10?
because we had to go by 5 this time. There was a fifth root. Yeah. So I had to do 5, 10, but that's the most I could get in 13. Now, 26, how many 5s can I take out of 26? 5, 10, 15, 20, 25. I'm still under 26, so I had to stop there, right? So I took 5 out, and how many were left in? Very good. And you have simplified, believe it or not, this is simplifying, this into 2x squared y to the fifth times the fifth root of 2x cubed y. Wasn't that exciting?
Okay, just do some problems.
Okay. I'm just going to make up 4 because, like I said, this is actually just the tip of the iceberg of this ridiculously loaded lesson. All right, here come your problems. How about we're going to do 1, 2, 1, 3, 1, 4, 1, 5. The square root. I'll even throw a number out in front of this one that you have to multiply by, just for kicks. 3 is the square root of let's see. Then we're going to have a cube root. Notice the top one is 3 times the square root. The second one is the cube root. The cube root we'll just stick with that same thing. That says y to the 6th, by the way.
I get 81 out of 50.
What?
I get 81 out of 10.
It's 2 different problems, Mark.
Yeah, 2 different problems. Maybe we'll just do 3 for right now. And the fourth root,
I always get confused on when to stop. When you know you're done. instead of
when you
multiplying.
can't do anything else. Oh, you never multiply it back. You just
Like,
stop.
I would do that.
Oh.
Like, if you got down to 9 times 10 or something, I would multiply 9 times 10.
Mm. There you go. Those are your 3 problems.